Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, basically, we're going to look at the review of stationary points. And this, in some cases, as we said, are going to be given the concept of a critical point. Now, in our previous discussion on the concept of the mean value theorem, and which special case is going to be given us the Rolle's theorem, we had said that we can have various range of points which we are going to describe for a particular range of intervals of point A and B on the, of course, Cartesian coordinate system for x and y. And we had said that for us to find the derivative for this specific point, the mean value theorem and the Rolle's theorem are going to be assisting us try to describe the nature of these specific curves at various intervals of A and B. And in a sense, we had decided that we can consider a point given in terms of this specific point, which is going to be given in terms of C, F, C on the a range of values between these specific, of course, points of A and B, of course, given as such. Or if we can give it in terms of this specific description, then we're going to have it given as A and B given as such. These are going to be the points along the x-axis which are going to be creating our particular intervals. And if we consider these specific points, then we can find a derivative of these particular two sets of points between a point A and B. So I'm going to give the coordinates of A and B given as such. So in this case, if we consider these two specific points, then we said that there's going to be a point for a continuous function on closed intervals of A and B, and a function that is differentiable between the open intervals of A and B. Then there's going to be a point in between A and B such that the derivative of this specific point at this point can be given at as or the first derivative of this specific, of course, point which we are going to give as f as c is going to be giving us the derivative of the points between A and B, and this is going to be given using this specific description for the mean value theorem. So in a particular case, then therefore we said we're going to come up with a range of a specific value depending on different types of graphs, and there are particular names which we are going to be giving in this particular case. Now, according to Rolle's theorem, of course, we're going to see that this specific theorem is going to be giving a special case whereby the value for this specific derivative is going to be given in terms of 0. So this implies that the value of a derivative at this specific point is going to be giving us a function, and it's not going to be change between f and fb and fa. So that has an implication that the values of fb is equivalent to the value of fa, which is equivalent to 0. And therefore, this specific description is going to be giving us a way of describing various range of graphs of these critical points. Now, such a kind of a point whereby C of FC equivalent to the derivative of this specific point of C given in terms of 0 is going to be giving us what we refer to as critical points. Now, we're going to consider a range of critical points for A, B, C, D, and E. And these are going to be described for a function of fx, or y is equivalent to fx of a differentiable function f. And this, as we said, this specific value of a function y is equivalent to fx is going to be consisting of values of x, where x is a range of real numbers. And as we have said, of course, for this specific case, we're going to have a specific point f, of course, c such that f prime over c is equivalent to 0. So therefore, these are going to be points which I've just given above. And as we said, the tangential component of this specific point is going to be a line parallel to the x-axis. And in this specific description from A to E, therefore, we're going to look at special cases of a description for these particular points, which is going to be describing the neighborhoods of these particular points. And in a sense, of course, that implies that these are going to be points towards the left hand side of this specific critical point, and the right hand side of this specific critical point. So we're going to evaluate the nature of course, the neighborhoods, or the trend of the curves on the neighborhoods of this specific, of course, critical points, and that's going to result to a various range of those specific points. So in a condition whereby we have said that we're going to have this particular constant given as such, so it's going to be described using the various curves for A, whereby we're going to have this specific function, or the first derivative with respect to this specific function over f prime over x is equivalent to 0, where I have said that basically this x is going to be a set of real numbers given as r, and x is equivalent to c in this particular case. So whenever I'm going to use this specific description for either c or x, that's going to be, of course, describing the same function. And we're going to see that this basically is going to create for us a basis of trying to describe the subsequent, of course, graphs which are going to be having the various critical points at these marked positions which I've given as such. And then for us to describe them, then therefore we are going to have this one giving us a point of reference. Now for B, we are going to see that we can describe these specific graphs whereby we're going to see the neighborhoods of this specific curve going down, and then there's a critical point, and then we're going to have it going up. And as we said, of course, from our previous discussion on derivatives on the mean value theorem, we had said that if we consider the trend of these specific curves for the x-axis going in that specific direction, for an increasing value of the x-axis, we're going to have a decreasing value of the y-axis. And from our previous discussion on the concept of a derivative, if we have a function whereby we're going to have a decreasing change on the numerator, and of course an increasing range of the denominator, this value is going to be a negative value. And therefore we can describe the trend of this specific curve on the left hand side, as I had just mentioned from my previous illustration, that is going to be having a negative trend. And at this specific point of a critical point, as we said, we are going to have a value of the derivative given as 0. And therefore on the right side, we are going to have the reverse of that, which is going to be giving us a positive trend. So which implies that there's a positive increase in the x direction, and as well a positive trend along the x, of course, the y direction. So we can describe this specific point in a sense that we are going to have this specific function of the derivative, which is going to be assisting us try to see this specific trend, whereby we're going to have the derivative of this particular value of x, of course, smaller than 0. So this implies that towards the left hand side, this is going to be smaller than 0, which is going to be a negative value. Sorry for that. But at this specific point as well, we're going to have it, so we're going to have the left hand side in contrast with the right hand side of a particular function. Therefore, we're going to have the left hand side for this specific description for B decreasing, and then we're going to have a right hand side of this specific function over f of x, of course, which is going to be a derivative greater than 0. So that implies it's going to be assuming of course, the values of this specific function. So in a sense, we're going to see that this is going to imply this particular trend, which I've basically given for the negative value of this specific function as 0, and then we're going to have a positive value. And this is going to be giving us a reference of what we refer to as a minimum point for this specific graph. So in a sense, we're going to have a function which is going to be describing this specific critical point that we refer to as a minimum point. And this is going to be the nature of the curves which we are going to witness for such a kind of description. So if you consider this particular value for the, of course, a graph of a C, we're going also to witness a particular trend whereby the neighborhood of this specific critical point which we have given in terms of a C being described by a function of this positive, of course, increase or a positive trend for the derivative, which can be given as such. There's a critical point at the center, and then we're going to have a negative, of course, a change for this specific value. So we shall have this specific derivative described over x given in terms of a value that is greater than 0 for the positive. And then, of course, we said that there's going to be a critical point at the center, and then we're going to have for the right-hand side a description of the function, which is going to be described as a function smaller than 0. So that's going to imply a negative. And then, therefore, we are going to have this critical point described in terms of a maximum given as such. And these are the two specific descriptions that we're going to get from this specific implication of those particular neighborhoods of the critical point of C. And we're going to see that in a sense we can describe this, have this specific description for particular functions which are not necessarily differentiable. And we're going to, of course, come across them in case I, of course, find that one in our subsequent videos. So we're going also to see that one in contrast with the two last points which we're going to have for D and E, and try to see which are the specific descriptions which we can as well give for those specific points. So in this specific case, we're going to see that we're going to have a description of the positive increase from this specific range of values for the neighborhood before the critical point. And then if we look at the neighborhood of this specific, if I refer to the neighborhood, that's going to be the trend of the curve, of course, of the adjacent point towards the right and left of these critical points. So this as well is going to be having a positive trend as such. So we can describe this specific range of values for the derivative for D given as f prime over x. At the left hand side of this specific point is going to be a positive value which is greater than 0. Then again we're going to have a critical point, and then we're going to have still the f prime over x, and of course this is going to be the right hand side being still greater than that. So such a kind of a description of a graph is going to be giving us what we refer to as horizontal. So this is going to be a forming horizontal point of inflection on what we refer to as a rising curve. So this is going to be giving a trend as we go along the x-axis. Of course, this is going to be having this specific particular change which is going to depict a rising curve. So we're going to have a horizontal point of inflection on a rising curve. And if we consider the second case, we're going to have this specific description for E given in terms of the trend on the x-axis being given as the first trend for the derivatives, which is going to be a negative trend. Then we're going to have a critical point, and then again we are going to have a subsequent negative trend given as such. So we're going to have the f prime over x in this case for the negative, which is smaller than 0. And then we're going to have a 0, and at the right hand side we are going to have this f prime over x given in terms of the decreasing value, which is negative, of course, given as such. So this is going to be giving us what we refer to as horizontal point of inflection on the decreasing curve, or on a falling curve. So kindly take note of the wording which we have been using this particular case. So for the first case, it's going to be having a horizontal point of inflection on a rising curve given as such along the x-axis, and for the second case, we're going to have an horizontal point of inflection on a falling curve given as such. So these are various range of description which we're going to be giving for critical points, and they're going to be assisting us much in trying to describe the concept of this curve sketching which are dimension. So kindly check our description boxes for various links of other videos, engage us in the comment section, subscribe, and ring that notification bell for a range of updates on topics under a similar discussion. So that is it for now, guys. Bye, God bless you. Catch us in our next video.